Take a look at this Freightliner Cascadia test truck. Beneath the sensors and cameras, this is a self-updating, highly integrated digital device. By 2027, Daimler Truck plans to have SAE Level 4 autonomous vehicles fully operational on public roads in the US. To make that happen, they formed a joint venture with Volvo to build a standardized operating system specifically for commercial logistics. The entire future of global freight now rests on software engineering. Code has overtaken the physical metal, disrupting 130 years of mechanical traditions. It all started in 1896. Gottlieb Daimler designed the world's first motor truck with a tiny 4-horsepower engine, a basic belt drive, and iron tires. Those early prototypes were immediately put to work hauling heavy beer barrels through Berlin. That simple utility proved that internal combustion could pull loads far more efficiently than horse-drawn wagons. As global trade expanded, the machines grew with it. By the 1960s, Mercedes-Benz was producing the Kurzhaube, or short bonnet truck, designed for extreme heavy-duty hauling. These machines earned a reputation for toughness. When the oil boom hit the Middle East, Kurzhaubers were sent to conquer unpaved Arabian deserts, regularly carrying up to 3 times their maximum rated weight without failing. The 1970s brought the NG, or New Generation series. This flattened, space-saving design established the classic cab-over silhouette that still dominates global logistics today. For an entire century, every problem in the supply chain had the same solution. To move more cargo, you added thicker steel, larger engine displacement, and more mechanical horsepower. That pure hardware approach peaked in the 1990s with the Mercedes-Benz SK series. The 1992 Euro 1 emission standards triggered a crisis. Pulling NOx emissions down to legal levels required detuning the engine, causing fuel consumption to spike 10%. Tweaking cast-iron locks could no longer balance pulling power with strict regulations. The hardware hit a physical limit. At the same time, global traffic volumes were surging. Roads became heavily congested, and accident rates climbed rapidly. And research showed that over 13% of truck drivers were suffering from chronic stress just from navigating the daily chaos. Steel and combustion alone couldn't fix a crowded highway or lower emissions without burning more diesel. Solving these dual threats required a completely new approach. The solution arrived in 1996 with the Mercedes-Benz Actros. This was the moment the industry moved away from brute force, introducing active electronic assistance systems. The truck uses external sensor cones to monitor blind spots. When it detects a pedestrian, it instantly triggers automated braking. Before this, safety meant a rigid cab. Now, by networking sensors, the truck actively prevents collisions before they happen. The Actros proved that an active intelligence to drive was becoming just as vital to the supply chain as the horsepower turning the wheels. Today, we are seeing the final stage of that shift. The internal combustion engine is being completely removed and replaced by a sustainable battery platform. Beneath the aerodynamic profile of the new e-Actros 600 sits an all-electric powertrain capable of generating 600 kilowatts of peak performance. It draws that power from massive lithium iron phosphate, or LFP, batteries. This specific chemistry removes the need for environmentally controversial elements like nickel and cobalt, giving the cells exceptional long-term durability. Operationally, this hardware can cover 500 kilometers on a single charge, and once the new megawatt charging system rolls out, it will take the battery from 20 to 80% in roughly 30 minutes. The physical truck has reached its peak as a high-performance hardware platform. All it needs now is a dedicated digital brain. This schematic shows the newest logic, decoupling hardware and software. The chassis is a standard base layer, while the operating system floats above it. Centralized computing lets developers push over-the-air updates directly to the vehicle, optimizing its code without a mechanic. This constant, wireless self-optimization is what drives the vision of accident-free driving. The truck adapts to new data and sharpens its reflexes every single second it spends on the road. In 130 years, commercial logistics has evolved from a 4-horsepower cart moving beer to a zero-emission digital node. Success in this new landscape means mastering the flow of data just as much as the flow of cargo.